numbers. And you're probably going to think this doesn't really relate to what we've been learning. It actually does. And so if you look at the definition of an imaginary unit, that is known as I. And that is the square root of -1. So back years and years and years ago, when they wanted to know how would you take the square root of a negative number, say for example I wanted to know the square root of -25, they said, well, we don't know how to take the square root of a negative number. So they invented I. I is the square root of -1. It allows you to take the square root of negative numbers. And so if I square this, it's like taking it times itself, right? Okay, that's where the -1 comes into play. All right. A pure imaginary number is just a number of the form bi. So what that means is it's just a constant in I. That's all it is. That's called a pure imaginary number. So now what we're going to do is we're just going to simplify. And so if you remember, okay, when we simplified and broke these down, what we would do is we would start and we would figure out two numbers that both go into 27. Okay? And what would it be? 3 and 9. And then can I break 3 down any? No. Can I break 9 down? 3 and 3. And do you remember now how I took things out? I take them in pairs. So I can take either these 2 3s or I could take any combination of 2 3s. And when I take a pair out, that means I take out 1. Now, is there anything else left inside the square root? What? 3. Now, we've got a -27, so since it's a negative, I'm going to attach I to my answer, and that's it. So we've already done this kind of in the past. We're just now attaching an I to our answer. So let's look at another one. The square root of -216. So I want you to go ahead and start doing that one.
Is the I inside or outside of the bracket?
Outside. That's a great question. Your I is always outside of the root.
How do you figure out which numbers?
You just trial and error. You could divide it by 2 and then you can divide it by 3.
Are people gonna have different answers?
Yeah. The bigger the number, the less you're going to have to multiply. And a good one that goes into this one is actually 6.
Also a 12.
They have to be prime numbers.
Prime numbers, if you start with like your 2s and 3s, will make it easier. You're just going to have, if you know, like what Chase has, look at how many branches he has. The bigger the numbers you use, the fewer the branches you're going to have.
Does it matter which number? Can you take out more than one pair?
So you have,
Yes, you can take out more than one pair.
So how do you do it?
Well, you can multiply.
pairs of
So 2 times 3 is
So if you just put 2 16 for calculator, is it the same answer as the
Come test time, I'm going to need to see work. I don't want to see that you can punch it in on your calculator. The calculator gives you the answer.
It does?
So.
Where's the ion?
Okay, so if you notice here, look at what I took out. Now, why could I stop here?
So you have to pair.
They're the same numbers, and I actually have a pair of 6s, right? So that means I can take out a 6. And I have a question. If I break 6 down, really, what does 6 break down into? 2 and 3. That's not a pair, right? So really, that's a way that I could write it. Now, for those of you that have like 2s and 3s, if you take out 2 pairs, you multiply those 2 numbers. So if you take out like a 2 and a 3, you would multiply those to get 6. Okay? But that's one of the things. You don't necessarily have to break it down into primes if you can kind of think ahead. Cool. All right, so let's go ahead and look at this one. Square root of -18.
How do you know which number is the right number? What if it's
It doesn't matter. You can do it totally different. I mean, I know Chase was doing it and he had it
What would I
told
do
you.
if I got this?
You've got a pair of 3s right here, boom, take it out. You've got a pair of 2s right here, take it out. So that's a
my
2
answer
times
would
3.
be 6.
Yeah, yeah. No, that's exactly what you got. 6 root 6.
I think it might get harder.
2 times 3 is 6. That goes outside.
It's getting
And then on the inside, you have another 3 and 2 right here. And that means it's 6 is inside. You had everything you needed there.
What if it's not a negative number? I mean, these are negatives, so what if it's not a negative number?
Oh, then you square it out. But you will have negatives. Okay, so 18. I could break down into 3 and 6. And I could break that down into 3 and 2. Or you could do 2 and 9. Okay? Take out a pair. You get a pair of 3s that you take out. What's left inside the square root? 2. And then I. The question came up, what happens if it's not a negative 18 and a positive 18? You just don't have an I. You do the exact same process. All right, so now let's go ahead and talk a little bit about this.
Okay, called it.
So, these are all of the powers of I.
We should probably write these
So
down.
first of all, yeah, that'd probably be a good idea.
This is one of those things that goes on the direct note. Those important things.
So first of all, I know that I equals I. I mean, that's just obvious. From what you wrote down from the first slide, what does I squared equal?
I squared equals 1.
Negative 1. Okay. So far those have been pretty easy, right? I cubed.
Negative 3.
Would you agree that that is I squared times I? Doesn't that give me I to the third? Okay.
So it's
I know I squared is what? Negative 1. So basically negative 1I. Or just, you could have negative I. What would I to the fourth be? I squared times I squared. What does I squared equal? Negative 1 times negative 1, which is positive 1. So do you see what I'm doing? I'm basically taking out I squareds because I know those equal negative 1. So I to the fifth will be I squared times I squared times I. Well, what do you know I squared is? Negative 1. I squared is negative 1 times I. What does that give me? 1I. What about I to the sixth? What would that be? I squared times I squared times I squared. Good. Which is negative 1 times negative 1 times negative 1, which is what? Negative 1. Do you notice a pattern? Let's look at the pattern. I, negative 1, negative I, positive 1. I, negative 1. What's this one going to be? Negative I, 1. What would I to the ninth be? I. So basically the powers of I repeat
What's the
by
difference,
4s.
what's the difference between negative 1i and negative I? There wasn't any difference, is it?
Negative 1I and positive 1I. Yeah, there's a big difference. One's negative, one's positive.
No, what's the difference between negative 1i and negative I?
Same thing. I mean, they're the exact same thing. So what would I to the 10th be?
Negative 5, 1.
Negative 1. What would I to the 11th be? Negative I. And I to the 12th would be positive 1. So see, it just repeats over and over. Now, why I'm showing you this is because if you ever take like one of those achievement exams, they'll sometimes ask you, what is like I to the 41st? Okay, and so then all you do is you just sit there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and you can go through and figure out where 41 is going to be. Okay, 41 actually would be right here. So I mean, it's kind of one of those things. If you ever take those achievement tests and they ask you for I to some big power, you figure out where does it fall, and that's how you can get the answer. So let's figure this out. I to the 31. Okay? So you could count and go 1, 2, 3, 4 all the way to 31. Or you could think these are all multiples of 4, right? So multiples of 4, let's see where we're at. Should put us right there. Why should it be negative I? This is 4, 8, 12. I to the 32nd would be right here. Okay, so I to the 31st is going to be right before it. So this one would actually be negative I. Okay, now you're going to have a few problems on your homework kind of like that. Yeah, not exactly that, but they'll be kind of. I mean, it's not going to be I to the 31st. So let's look at the bottom one. Now this one's a little different. Because here, what I'm going to do is I'm going to take negative 5 times positive 3. What is negative 5 times positive 3? Negative 15. What is I times I? I squared. But what do I know I squared is equivalent to? Negative 1. So really I have negative 15 times negative 1, which is 15. There you go. So whenever you have an I squared, you have to replace it with a negative 1.
How does affect our everyday lives?
Well, it's not an application. Okay, this actually, there's a lot of stuff in calculus that will deal with the I's and your advanced math. So-
Is this like a theory thing?
No, this is how you'll do it. So, you have square root of negative 20 times square root of negative 12. Okay. So really, this is what I do. I know a lot of people would say, oh, well, negative times a negative is a positive. The problem when you do that is you're actually going to be off the sign. Okay. So now let's break down 20. What would be two numbers that I could break 20 down into? 5 and 4. What about 4? 2 and 2. Let's break 12 down. 4 and 3. 2 and 2. Now what we're going to do is we're going to treat this as one big problem. So we're going to take out the pairs, combine them both together. So I have a pair of what? 2's and a pair of 2's. So what do I take out? 2 times 2, which is 4. Square root, what's inside? 15. And then last but not least, I have an I and an I, which is I squared. Okay, that's 5 times 3. So what is I squared equivalent to? Negative 1. So really your answer is negative 4 root 15. Okay, so the biggest thing what I don't want you to do is I don't want you to start by multiplying 20 times 12 and get 240. Okay, because essentially you're going to have to break it down anyway. So you're better to start with the 20 and the 12 individually. What?
Like when we broke down the 20 and the 12, could you have stopped the 5 and the 4 since they were the same?
Well, you could have. The only problem is you run into problems here with the 12 because you have to break that one down too. And so, yeah, I mean, you probably could have stopped there on this one. I don't know about necessarily on all of them. Yeah.
Why do you multiply, or why is it negative 4 and not negative 15?
Because this is negative 4 times root 15. It's the negative quantity. It's like one term. Okay, here we go. We're going to look at how you can solve this quadratic. So this is kind of where it relates to what we've done in the past. The difference is that this is now a plus, whereas before it had been a minus. Okay. So to solve this, let's subtract 64. Now how do you undo something that's squared? You take the square root. The important thing about whenever you take a square root is that you take both the positive and the negative. So x equals plus or minus. And then now the question is, I've got a negative 64. So I need to break 64 down. What do I know 64 breaks down to? 8 and 8. Oh, I have a pair, right?
Boom.
So I can take that out, and my answer will be 8i. Okay, why did I need an I? Because it was a negative 64.
Why is that x squared then just x?
The square root of anything that's squared will be whatever the original. Okay, let's look at this one. 4x squared plus 100 equals 0. So there's two ways to do this. You could subtract 100 first, or you could divide by 4. It doesn't matter. So you get 4x squared equals negative 100.
Did you divide by 4?
Divide by 4, and you get x squared to equal negative 25. So now how do you solve that for x? Square root. Important thing to remember is always the plus or minus.
How did you do it on 4?
I just divided both sides by 4. So you get x to equal plus or minus 5i. Nice job.
So to do the original, without dividing by 4 would be 1, so you get 2x squared.
Yeah, you can't do that. Okay. Alrighty, let's look at another one and see what we have next. We're going to now talk about complex numbers. Okay? Basically, a complex number is any number that can be written in the form a plus bi. A is your real part, bi is your imaginary part. So instead of numbers just being pure imaginary, they can be complex, which is what these are.
What do you mean by imaginary?
All right, so these next few problems we're going to look at, I don't think you'll mind too much. Okay?
Mind as in like or mind as in...
I don't think you'll mind because they're pretty straightforward. Okay, so, alrighty, so let's go ahead and look at this. Okay, now, when you solve these problems, you need to treat the I very similar to a variable. You're going to treat it like an x, or a y, or an n. So as I look at that problem, it's actually going to take you longer to write it down than it will be to solve. If you look at that, what do you think the answer will be to number 1?
7 minus 3i.
7 minus 3i, and that's exactly right.
Oh.
All you do is you combine the real parts and you combine the imaginary parts. So I combine the 5 and the 2 to get 7, right? And I combine the negative 7i and the 4i to get negative 3i. There's no catch. This is how you do it. You treat it just like a variable. And so here, on this bottom one, when it says to subtract, my suggestion, switch, switch. Okay, change it to addition. What? Yes. Switch those two. By switching those two, you've made it an addition problem. And it should be fairly easy. Because now, what do you get from this? 1, 2i. Okay, so find the values of x and y that make this true. Find the values of x and y that make this true. Now you're going to see some of these on your homework. And once again, this is one of those that I think once we go through the problem, you'll be like, well, that's not bad at all. Okay. So all we're going to do is we're going to correlate the two. What does 7 correspond to on the left? What?
Positive then?
What does 7 correlate to on the left side?
Negative 5. Negative 5.
Okay, let's try the I first then. Let's see what the I, what does the 6 correspond to?
So y minus
Y minus 3, there we go, good job. Because basically, it's the numbers in front of the I, right? They relate. So I know that y minus 3 has to equal 6. So what does y equal? 9. Okay? Now with that in mind, since we got that one out of the way, that was kind of easier to see, what does 7 correlate to?
3x minus 5.
3x minus 5, there we go, nice job. So I know that 3x minus 5 equals 7. So 3x will equal what, folks? 12, and then x equals 4. So that is how you solve those problems. You just equate the real parts and the imaginary parts. Okay, so do we need to look at this one or do you think you have it down?
Good.
What would 5x plus 1 correspond to?
2x minus
2x minus 2. What would the 3 plus 2i correspond to?
1 minus 6 and I.
Okay, and you would solve those equations. All right, last thing we're going to talk about are complex conjugates, and this is the last type of problem you're going to have today. Okay, complex conjugates, a plus bi times a minus bi. This is the last example. So what I wrote up there is an example of two complex conjugates. Basically, they look real similar to the difference of two squares that we looked at. First terms are the same, last terms are the same, signs between them are different. So when it says to simplify in that example, you need to get rid of the I in the denominator. We can't have this, it's like taboo. It's like a square root in the denominator. Can't have it. So in order to get rid of that, you're going to multiply by the conjugate. So what would the conjugate of 3 plus 6i be? 3 minus 6i. Now, you have to multiply both the top and the bottom.
You always have to take the
Yes, you always take the conjugate of the denominator. So really, what ends up happening is, I have 2i times 3 minus 6i on the top. On the bottom, I have 3 plus 6i times 3 minus 6i. Okay. So what do you have to do on the top? Distribute. And I get 6i minus what? 12i squared. Now on the bottom, there's a little trick with conjugates. Normally, you would have to FOIL those out, right? With conjugates, all you have to do are multiply the first, so I get a 9, and the last, because the middle terms will always drop out. They'll always cancel each other out. So what is 6i times 6i? 36i squared. Now we're about done, but what do we need to do?
circle.
I squared is -1. So on the top, I have 6i plus 12, yep. On the bottom, six I plus 12, because this is minus 12 and the negative 1, which is plus 12. So on the bottom, you really have 9 minus negative 36, which is 45. But that's not quite your answer. Why? You can reduce it. What can you reduce it by?
2's. 12.
Who said it?
6.
3. 3 goes into 6 how many times? 2. 3 goes into 12. 4. 3 goes into 45? 15. There you go. Okay, long lesson today, but remember, you're not going to be here tomorrow.
Oh, yeah.
So,
Why is it?
because 9 minus negative 36. I'll come back. Okay, so here you go. Pages 250, 251, 18 through 52 evens. Those of you that are gone tomorrow, you're going to have to find time to get that done, okay, for Thursday. Those of you that are here tomorrow, like 3 of you, you will have the entire period to work, okay? 18 through 52, the evens.